We've looked at graphing the basic inverse trig functions, but let's see how we modify them a bit. Something like this, instead of just inverse sine of x, 5 times the inverse sine of x on 3, all we really need to do is work out what the domain and range are going to be of this new function. Now we know the domain and range for the basic inverse sine graph. The difference is, instead of inverse sine of x, we've got x on 3. So instead of x going in between minus 1 and 1, x and 3 will go in between minus 1 and 1. So we can easily work out the domain. Oh, it's going to be minus 3 to 3. We can do a similar thing with the range, but it has to equal the inverse sine function. So in other words, when we're looking at the range, we'll have y on 5, because I divide both sides by 5, so I've got it equaling the inverse sine function. So y on 5 will go in between minus pi on 2 and pi on 2, so our range will be minus 5 pi on 2 to 5 pi on 2. But other than that, it will look exactly the same. And so essentially I can draw an identical graph. It's just that what I label those points are going to be different, but it's still the same picture. There's 5 times the inverse sine of x on 3. Let's do this one. It's a little bit more interesting. Inverse tan of the square root of 3 minus x squared. Now, of course, inverse tan, the domain was all real x, but we've got an additional function to worry about here. That square root of 3 minus x squared is going to restrict the domain on what we're looking at. So we're going to have to consider that. The 3 minus x squared is greater than or equal to 0. I mean, other than that, it would have been all real x, but we've got to satisfy this as well. Ours is going to be restricted between minus the square root of 3 and the square root of 3. What's that going to do to our range then? Well, when I have a restricted domain, if I'm unsure, and especially with these symmetric graphs, an inverse tan's a symmetric graph, I'll check the endpoints and I'll check the midpoint. So root 3, well, that would give me the inverse tan of 0, which is 0. Negative root 3, I suppose I didn't really need to check negative root 3 because of the symmetry. As expected, it is 0 as well. Let's have a look in the middle. And in the middle, it's pi on 3. Now, because I know the inverse tan graph's continually increasing, then I know, all right, it must go between 0 and pi on 3. What does it actually look like? So let's mark those points, and we end up with this sort of shape. It's very close to looking like a semicircle, isn't it? It's got that sort of shape to it. Okay, whoa, hang on. The inverse sine of sine x. Tempting just to draw y equals x. But remember, inverse sine of sine x is not necessarily going to be x, because inverse sine will only produce answers that are negative acute or acute. So our domain, it's still an inverse sine function, but instead of inverse sine of x, it's sine x. So we're saying sine x has to go in between minus 1 and 1. Well, when does sine x go in between minus 1 and 1? Well, it always does. So the domain for this is all real x. I can substitute anything in, and I will get an answer that's in between minus 1 and 1. All right, so it's going to go complete. But what about the range, though? Well, the range, that's not going to change. It's an inverse sine function. I'm still going to be restricted between minus pi on 2 and pi on 2. Well, let's draw this thing up. So I'll mark off those points. As I say, I know it's based on the line y equals x. So I know that bit's going to be there. There's y equals x. But what does it do? Now, I can test some points and find out where I am. But what it ends up doing is zigzagging like that. So if you're unsure how it's going to go, just pick a few points and you'll find out where it goes. What about the other way round then? What if we said the sine of the inverse sine of x? Again, you'd think, oh, well, it's y equals x. What's the domain now? Wow, well, the domain now is restricted between minus 1 and 1 because we're substituting the x into the inverse sine function. And we know the domain of that is minus 1 and 1. What's going to happen to our range? Well, let's check. X equals 1, I end up with 1. Makes sense, y equals x, kind of expecting something like that. Negative 1, it's negative 1. What about in the middle? 0, it's 0. Looks like our range is the complete range of the sine function, minus 1 to 1. Let's draw it. It's based on y equals x, but it's just that piece of the line. So the first one, it's zigzagged along, whereas this one is restricted, minus 1 to 1. They're both based on the line y equals x though. 17C then, let's draw some different looking inverse trig graphs.